A curve is concave if its gradient is decreasing. We can see that this red region of this graph is concave, its gradient is decreasing. We see here that it has a very large positive gradient, it's very steep and going upwards. Here there's a stationary point, so that gradient is 0, and on the other side of that stationary point, its gradient is negative. So in this whole red region, the gradient is decreasing, it's concave. On the other hand, in this blue region, we see it's convex. Now, a curve is convex if its gradient is increasing. Let's have an explore of this blue line and see that its gradient is increasing. To begin with, its gradient is negative, then its gradient is 0, and then we have some positive gradient. So we see that the gradient is increasing all the way through this blue line, so it is convex. If something is concave, its second derivative is less than 0, and if something is convex, its second derivative is greater than 0. Exactly at that point of inflection, which is where we switch from concave to convex or from convex to concave, we have a point of inflection, and at this exact point, our second derivative is 0. It's switching from either being negative to positive, in the case of going from concave to convex, as is in this figure, or we go the other way, we go convex to concave, where we have that gradient for that second derivative going from positive to negative. So let's have a look at this. Example, find the set of values for x for which the curve with the equation f of x equals x cubed minus 2x squared minus 4x plus 5 is concave. Now we know something is concave if d squared y over dx squared is less than 0. We can also write this in function notation, so we can say where f double dash x is less than or equal to 0. So let's just find this quantity, f double dash x. We'll insert it into this inequality and solve for our answer. So firstly, f dash x, I'm differentiating my function once. That will give me 3x squared minus 4x minus 4. I'll differentiate that a second time. So I have f double dash x equals 6x minus 4. And now I'm going to insert that into this inequality and solve it to see where it is concave. So I'm going to say 6x minus 4 is less than or equal to 0. So that becomes 6x is less than or equal to 4. X is less than or equal to 4 divided by 6. So x is less than or equal to 2 over 3. Okay, let's look at this next question. Show that the function g of x equals 4x to the power 4 plus 3x squared plus x minus 1 is convex for all real values of x. Well, let's remind ourselves the condition for something being convex. So something is convex when its second derivative is greater than 0. So when g double dash x is greater than or equal to 0. So let's find this quantity g double dash x. Firstly, let's differentiate once. So I've got g dash of x is going to be 4x cubed plus 6x plus 1. And I differentiate that a second time. So I have g double dash x equals 12x squared plus 6. Now, I know x squared is going to be positive. So x squared is greater than 0. That means I know 12x squared is greater than 0. That means, so because 12x squared, x squared is greater than 0, therefore 12x squared is greater than 0, and therefore 12x squared plus 6 is greater than 0. So I can say, therefore, g double dash of x is always greater than or equal to 0. So g of x always convex. Okay, last one. Show that the graph y equals x cubed minus 3x squared plus 14x plus 8 has a point of inflection at x is 1, y is 20. Well, let's remember the condition for a point of inflection. We have a point of inflection where the second derivative equals 0, okay, and changes sign on either side. So let's stick with y notation, and let's firstly find this second derivative. So we're looking to see if d squared y over dx squared, does that equal 0 at the point x equals 1? That's what we're investigating. So firstly, let's differentiate once. So I've got dy over dx equals 3x minus 6x plus 14. And then I have d squared y over dx squared. I'm differentiating this second time. Sorry, that should be an x squared there. That becomes 6x minus 6. And now let's investigate. Is d squared y over dx squared 0 at the point x equals 1? Well, if I have x equals 1, I'm going to substitute a 1 in for every x. So that becomes 6 times 1 minus 6, which does equal 0. So there is a point of inflection. Hope that helps.